Hi friends, in today's video we have to calculate the hardness of the water sample in terms of equivalent of CaCO3. In the question given data is 0.81 gram of calcium hydrogen carbonate and 0.73 gram of magnesium hydrogen carbonate. This is given. 100 ml of water sample is given and molar mass of magnesium hydrogen carbonate and magnesium it is over and calcium hydrogen carbonate is given. Some data is given, but directly amount of CaCO3 in that water sample is not given. So we have to calculate the hardness in terms of CaCO3. First of all, we should know what is a ppm, that is parts per million. Just like a percentage where the number of parts in a 100 parts of sample, where there is an ppm, a number of parts in 10 raised to power 6 part of the sample. This is called ppm. This is the first question of this problem. And second part, as directly the amount of CaCO3 is not given, we have to convert that magnesium hydrogen carbonate and calcium hydrogen carbonate into a equivalent amount of CaCO3. Then in that case only we can find the hardness of the water sample in terms of equivalent of CaCO3. You have to remember directly CaCO3 is not given. So we have to convert whatever amount of calcium hydrogen carbonate and magnesium hydrogen carbonate is given, we have to convert in CaCO3. So you say there is a 0.81 gram of CaCO3, it is given. Means 0.81 gram of calcium hydrogen carbonate is given. This is given. Now first of all you have to convert the 0.81 gram of calcium hydrogen carbonate into the equivalent amount of CaCO3. It is very simple how to convert this. Now here in CaCO3 there is a 1 mole of calcium. In 1 mole of calcium hydrogen carbonate, how much calcium is there? That much calcium only can be converted to calcium carbonate. That means in this there is a 1 mole of calcium hydrogen carbonate here equivalent to 1 mole of calcium. Okay. In terms of mole, 1 mole of calcium hydrogen carbonate is equal to 1 mole of calcium. And in CaCO3 also 1 mole of calcium carbonate equivalent to 1 mole of calcium. Okay. Now 1 mole of calcium and 1 mole of calcium both are same. So we can say that 1 mole of calcium hydrogen carbonate equivalent to 1 mole of calcium carbonate. This is equivalent. That means from 1 mole of calcium hydrogen carbonate we can only form 1 mole of calcium carbonate, not more than that, not less than that, because in 1 mole of this we have 1 mole of calcium, so 1 mole of calcium we can use to form a 1 mole of CaCO3. Now what is 1 mole of calcium hydrogen carbonate? That is the given 1 mole of CaCO3 is equal to 162 gram. 162 gram is equal to molar mass of this is 100 gram. That means 162 gram of this equivalent to 100 gram of this. So how much amount of this is given? 0.81 gram, and it is equivalent to what? So we have to calculate x. So x is equal to cross multiplication 100 into 0.81 divided by 162, and its calculation comes 0.5 gram. Now we have converted this 0.81 gram of calcium hydrogen carbonate into the 0.5 gram of calcium carbonate. Now we have to convert this 0.73 gram of magnesium hydrogen carbonate. 0.73 gram magnesium hydrogen carbonate. How to convert this into the calcium carbonate? Now you see here is a magnesium and calcium, both are having the same valency, that is +2 +2. So we can say that 1 mole of magnesium hydrogen carbonate equivalent to 1 mole of calcium hydrogen carbonate, because we can replace this magnesium by calcium ion easily because valency is same, and this 1 mole of calcium hydrocarbon carbonate is equal to 1 mole of calcium carbonate. Okay, these are equivalent. So how much? 1 mole means magnesium hydrogen carbonate is equal to 146 gram equivalent to 100 gram of CaCO3. How much amount of magnesium hydrogen carbonate is given? That is given 0.73. So 0.73 gram is equal to how much gram? So we can easily convert. So X is equal to 100 into 0.73 divided by 146. Its calculation comes 0.5 gram. Now we have both converted, that is hydrogen, calcium hydrogen carbonate and magnesium hydrogen carbonate in terms of CaCO3. Now we have to find total amount of this CaCO3. In terms of magnesium hydrogen carbonate, it is 0.5, and in terms of calcium hydrogen carbonate, it is 0.5. So total is 0.5 plus 0.5 is equal to 1 gram. Okay, total amount comes 1 gram. Now we know in 100 gram of sample we have 1 gram of CaCO3. 100 gram of sample, because 100 ml is given, density is not given, but we can assume water density as a 1. We have to forget about this 0.81 and 0.71 gram because they are very less in amount. So we can directly take 100 ml of water is equal to 100 gram of water. So in 100 gram of water we have 1 gram of calcium carbonate. So in ppm there should be 10 to the power 6 part of water, and that part we are taking in gram. So in 10 to the power 6 gram, how much CaCO3? So that will be our ppm. So X is equal to, so we can write X is equal to cross multiplication 10 to the power 6 into 1 divided by 100. So it is coming 10 to the power 4 ppm. Okay, so X 10 to the power 4. 10 to the power 4 is nothing but a 10,000 ppm. So this is the answer of this question. Hope you like this solution. If you not subscribed to my channel, then subscribe to my channel right now, because I need your support to grow my channel and to make more videos. And friends, thank you for watching this video.